as we begin our study of trigonometry, we'll need to look at a lot of new definitions and some old definitions and make sure that we learn these as we go along. The first definition that we want to look at is what an angle is. And an angle is formed by two rays with a common endpoint called the vertex. So we would have two rays and they have this common endpoint called a vertex. And so this would be then what we would refer to as an angle. Now, when we draw our angle, we have to give some things. We can label it by points on the edge or on the sides. So we could call this A, we could call the vertex O, and we could call a point on this side B. And so this could be called angle AOB. Could be called angle BOA. And if it's an angle by itself, it could be called angle O by the name there. Now, most of the time, though, we will give the angle a name. And so the name that we normally give would be a Greek letter, and often we'll use the Greek letter theta. And so we could call this angle theta. That looks like an O with a loop through the top. We'll use other Greek letters in this study. We'll use the Greek letter alpha. We'll use the Greek letter beta. And most of the times when we label angles, we'll label them with Greek letters so that you'll know which are angles and which are sides. An angle, as we describe it, it will have an initial side, which is the side where it begins, and it will have a terminal side where it ends. It's important to know which side is the initial side and which is the terminal. So what we'll do is we'll start on the initial side and we'll draw a little arrow to the terminal side. And that becomes very important as we study our angles, because if an angle rotates counterclockwise, which is our normal rate of rotation, then we will refer to it as a positive angle. So this angle up here would be a positive angle because it's rotating counterclockwise. If our angle rotates clockwise, then we will refer to it as a negative angle. And all that this means is which direction it's rotating. It's just telling, the same as with our numbers. Numbers to the right of 0 we call positive. Numbers to the left of 0 we call negative. So if I drew an angle, and I wanted to draw the angle of 30 degrees, then I would have my initial side. I'd have my angle of rotation, I'd have my terminal side, and that would be 30 degrees. If I wanted to draw an angle of negative 30 degrees, I have my initial side, I have my direction of rotation, and my terminal side, and that would be negative 30 degrees. So it's important as you draw the angle to distinguish which way that it's rotating. Now we're going to talk about degrees, and so we need to define those. And 1 degree is equal to 1/360th of a rotation. So a degree is referring to an amount of rotation. We have some special angles that we'll refer to. A right angle is an angle that measures 90 degrees. And we'll mark a right angle by putting a little square in the corner. A straight angle is an angle that measures 180 degrees. So it would simply be a straight line. And we would have our angle. Uh, if an angle is between 0 degrees and 90 degrees, then we refer to that as an acute angle. We don't call a 90-degree angle an acute angle because it has a special measure. It's 90 degrees. If an angle is between 90 degrees and 180 degrees, then it's called an obtuse angle. So we have some special angles that we will refer to, and this is what we mean by these angles. Another definition that we'll look at is for complementary angles. Complementary angles are angles that have a sum of 90 degrees. And so if we wanted the complement of 30 degrees, well, we know that 30 plus some angle would be 90, so 90 minus 30 degrees. The complement of 30 degrees then would be 60 degrees. The complement of 20 degrees would be 90 minus 20, or 70 degrees. The complement of 81 degrees would be 90 minus 81 degrees, or 9 degrees. So if we had x degrees, then the complement would simply be 90 minus x. And so that gives us then a formula for finding the complement of any angle. We also have what are called supplementary angles. Supplementary angles are angles that have a sum of 180 degrees. And so if we had 20 degrees, the supplement of 20 degrees would be 180 degrees minus 20 degrees, which would be 160 degrees. The supplement of 70 degrees would be 180 degrees minus 70 degrees, or 110 degrees. The supplement of 165 degrees would be 180 degrees minus 165, or 15 degrees. So the supplement of x degrees would be 180 degrees minus x, whatever that angle is. So again, that gives us a formula for finding the supplement of an angle. Now, if you have two adjacent angles, these are simply angles that share a common side that are supplementary, then they're going to form a straight angle. If we went back to right angles, if you have two angles that are adjacent, they share a side, and they're complementary, then they're going to form a 90-degree angle. And that will help us as we're solving some of our triangles. One of the types of triangles that we use quite often is a right triangle. And so we're going to look at some of the things that deal with a right triangle. A right triangle is simply a triangle that has a right angle. Now, we're familiar with the Pythagorean theorem, which if we call this side A and this side B and our hypotenuse C, then we know the sum of the squares of the two legs is equal to the square of the hypotenuse. So a squared plus b squared equals c squared. Knowing that, we can solve any right triangle if we know that it's a right triangle. So let's say we were given a right triangle and side A equaled 6, side B equaled 8, and we want to find side C. Well, A squared, so 6 squared, plus B squared equals C squared. So that's 36 plus 64 equals C squared. 100 equals C squared. Taking the square root of both sides, plus or minus 10 equals C. Since we're talking about a distance, it will always be the positive. So 10 equals C. Let's look at another one. Let's say that we were given, and in this case it's going to be, we'll draw it on the triangle because sometimes that's what you'll see instead of being given A, B, and C. You'll be given a diagram. So we have a right triangle. We're told that this side is 5 and this side is 5 square roots of 2. We want to find this side, which we'll just call x. Now, if we were going back to given, we're given one leg and the hypotenuse, we're trying to find the other leg. Well, we still go back to our Pythagorean theorem, so the sum of the squares of our legs, so x squared plus 5 squared equals 5 square roots of 2 squared. So x squared plus 25 equals. Now, here we have a product being squared. If you remember back to algebra, we have a theorem that says if you have a product being raised to a power, then you're raising each one of those factors to that power. So in this case, this is going to be 25 times the square root of 2 squared is 2, so that being raised to the power would be 50. So then to solve, we would subtract 25 from both sides. So x squared equals 25, and x equals plus or minus the square root of 25, which would be plus or minus 5. And again, this is talking about a length, so it would be 5. So we could solve then our triangle. Often they may be given, instead of just being given a value, we might be given a relationship. So let's say we have a right triangle. We're given in this case that the hypotenuse is 5. We don't know this leg, and all that we know about this leg is that it's one less than that. And so we want to solve. So we'll set it up the same way. You always go back to your formula. So our formula says the sum of the squares of the legs, so x squared plus x minus 1 squared equals the hypotenuse squared. We're going to square this, so we have x squared. Now, when we square a binomial, remember you go back and you use your distributive property, or some of you learned the word FOIL, and so we would multiply x minus 1 times x minus 1. What you would get here would be x times x times negative 1, negative 1 times x, and negative 1 times negative 1, which is 1. So we have x squared plus 2x, minus 2x, plus 1 equals 25. Now we have a quadratic, so we have 2x squared minus 2x, and we need to get it equal to 0, so we'll subtract 25 from both sides. 1 minus 25 is negative 24. Anytime you solve a quadratic, you want it equal to 0. Now you have some options. You can solve this quadratic by factoring, or you can solve it by the quadratic formula. I'm going to solve it by factoring. So I look, and there's a common factor of 2. So I factor out a 2, and I have x squared minus x minus 12 equals 0. And now I want to factor my trinomial. My coefficient's 1, so I can factor it. I want factors of 12 that subtract to be 1. Well, that's 3 and 4. I know because I subtracted, the signs are different. That's how I got a negative 12. I get this last number by multiplying these two together. So the signs are different. This I got by adding or subtracting, and it took the sign of the larger. So it's a negative 4 and a positive 3 equals 0. Now we said each factor equal to 0. Well, we know that 2 doesn't equal 0. So x plus 3 equals 0. Subtracting, x equals negative 3. Or x minus 4 equals 0. Adding 4, we get x equals 4. Well, we're talking about a length, so it can't be negative. So x would equal 4. If we fill that in, then this side is 4 and this side is 3. Now, if you're not comfortable with factoring your quadratic, then remember you can always use the quadratic formula, which says x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so you could solve your quadratic using that. Most of the quadratics we'll be solving in trig will be factorable and easily factorable. Now, we just looked at a triangle that the sides ended up being in the ratio, excuse me, of 3, 4, 5. And we have some special triangles. They're called Pythagorean triples, and they're always, and the sides are always in the same ratio. So it's nice if you know your Pythagorean triples. And there's some that you're probably already familiar with, such as the 3, 4, 5. So your sides are always in that ratio. The largest one's always the hypotenuse. So you might have a triangle of 3, 4, 5, or it could be a 6, 8, 10, where each of those is multiplied by 2, or a 9, 12, 15, as long as the ratios reduce down to 3, 4, 5. Some others that you may not be as familiar with is a 5, 12, 13, 8, 15, 17, and a 7, 24, 25. Now, these are going to come up fairly often, and so you might want to remember those. There are other Pythagorean triples. We won't use them as often. There's a 20, 21, 29, and there's others. But these are right triangles that are always in this ratio. When you have a triangle where the sides are in this ratio, then you'll also note that it's a right triangle. So you might be aware of those. Okay, we do have some special triangles that we will use quite often, and you'll want to make sure that you know these and you know the ratios. And so we want to spend a little time and look at those as we go through. And the first one we want to look at, and again, you probably studied these when you studied geometry, but the first one we want to look at is what we call a 30, 60, 90. And when you have a triangle that the angles, we're talking about the angles here, not the sides. The Pythagorean triples, we were talking about the ratio of the sides. And here, when we talk about a 30, 60, 90, the angles are 30 degrees, 60 degrees, and 90 degrees. And the sides do have a special ratio. When I want us to look at how we come up with this. So we're going to have a triangle that's an equilateral triangle, meaning that all the sides are equal. And I may not draw it exactly that, but if we have the sides equal, we can pretend, if I don't get it quite right. Okay, and that's pretty close, though I know that it's not exactly an equilateral triangle, but we do know in an equilateral triangle that the angles are all 60 degrees because there's 180 degrees in a triangle, So that means each of your angles is 60 degrees. So what we're going to do is we're going to make a perpendicular bisector of the vertex angle. Now when we do a perpendicular bisector of the vertex angle, since this is an equilateral, it also bisects the base. And it bisects it at a right angle. So we've got us a triangle now, and this bisected, whew, was fun. This bisected the base at a right angle. So we know that we have a right angle here. And we know it bisected the angle, so we know that this angle up here now is 30 degrees. Well, we want to see then what we know about this. We're going to, we know that all the sides are the same, and we're just going to let each side be 2x. We could let it be anything. We're going to let it be 2x. And so this big side down here is 2x also, which means when I bisected the side, that this side is now x. So we have our right triangle. We have a 30, 60. The side opposite the 30 we're calling x. We can use our Pythagorean theorem then to find what the height of that triangle is. We know that x squared plus, let's just call this b, plus b squared equals 2x squared. So subtracting, well, first of all, let's square that. So x squared plus b squared equals 4x squared. Remember, you have to square both of the factors. Now subtracting, b squared equals 3x squared. Taking the square root, and I only need the positive one. I want the square root of 3x squared. Well, I can't take the square root of 3, but the square root of x is x. And remember, we always say it's the absolute value of that. So we now have a ratio for the sides of our triangle. This side it would be, the height would be x square root of 3. So let me just try to draw a right triangle over here. What it turns out then, our sides are always in a particular ratio. If this is our 30-degree angle and this is our 60-degree angle, okay, the side opposite the 30-degree angle is half the hypotenuse. So I'm going to call this one x, so the hypotenuse would be twice that. The side opposite the 60-degree angle is always the short side times the square root of 3. And your sides will always be in that ratio. Now that means then that if we have a 30, 60, 90-degree triangle, and we know one of the sides, any of the sides, then we can go about and we can solve it. So let's take this one. We'll say that this is 30 degrees and this is 60 degrees. Here's our right angle. And let's just say that we're told that the side opposite the 30-degree angle was 5. Now we want to find our other sides. Okay, what I would do is go through and put in my ratios. I know the side opposite the 30 is half the hypotenuse. So if it would be x, the hypotenuse then would be 2x. The side opposite the 60 is the short side times the square root of 3. Now I have my equation. So x equals 5. So 2x equals 10, 2 times 5. And then the side opposite the 60-degree angle, x square root of 3, would be 5 square roots of 3. and we've solved our sides of our triangle. Now, let's say that we were given a triangle, and our sides, this is a 30-degree, this is a 60-degree, and let's say instead of our short side being 5, let's say that our hypotenuse is 5, and we want to find out what our other sides are. Okay, we start out the same way. The side opposite the 30-degree angle we call x. Our hypotenuse is twice that. The side opposite the 60-degree angle is x square root of 3. There's your equation. 2x equals 5. So x equals 5 halves. So that means this side over here is 5 halves. And then x square roots of 3 would be 5 halves times the square root of 3, which we can make a little bit simpler, 5 square roots of 3 over 2. So this side would be 5 square roots of 3 over 2. And it made it fairly easy to solve. Okay, let's do it one more time. And we'll draw our triangle. Make this our 30-degree angle. This our 60. And this time we're going to let the side opposite the 60 be 5. Well, again, we go through. Our ratio is the side opposite the 30 is half the hypotenuse, so the hypotenuse is 2x. The side opposite the 60 is the short side times the square root of 3. So here's our equation. X square roots of 3 equals 5. So by doing this and setting it up with that ratio, then whichever side you're given, you've got your equation, and you can solve. We want to solve for x, so we'll divide both sides by the square root of 3. And we can rationalize. We'll multiply both our numerator and denominator by the square root of 3, so we have 5 square roots of 3 over 3. Now, if we were able to reduce these numbers outside the radical, we would, but we can't. And so we have x square roots of 3. We now know that x is 5 square roots of 3 over 3. And our hypotenuse is 2x, so it's going to be 2 times that, so it would be 10 square roots of 3 over 3. So our hypotenuse is 10 square roots of 3 over 3. So by knowing one side, then we're able to solve for all the others. Another triangle that we have that's a special triangle is a 45-degree triangle. So we're going to look at a 45, 90-degree triangle. Now to see where this comes from, let's draw a cube. And a cube simply means all the sides are the same. So we have 90-degree angles, and we're going to let the sides be x. And we draw a diagonal of the cube. What that's done is that's made us a right triangle. Where the sides are the same, we bisect, since it was a cube and that was 90 degrees, our diagonal bisected it, and so we know that this is 45 degrees. Now, we need to find the length of the diagonal, so we'll use our Pythagorean theorem that x squared plus x squared equals our diagonal, or we'll call it r squared. And so we have 2x squared equals r squared. Taking the square root, that will equal r. Well, we can't take the square root of 2, but the square root of x squared is x. And so our diagonal then is x, the side, times the square root of 2. And we can use this then to solve some right triangles. So let's say that we have a triangle. We're told that this is 45 degrees, and it's a right angle, so this other one has to be 45, even if we're not told. And let's just say we're told what one of our sides is, that this side is 3. Well, we know then that this other side is 3 because they have the same length, or we could have labeled it x, x, and this side is the hypotenuse is the side times the square root of 2. And so we've got this side then is going to be 3 square roots of 2. It will be whatever your side was times the square root of 2. Now, if we were given a right triangle where our angles were 45 degrees, and let's say in this case that we were told that it was our hypotenuse that was 3, and we want to find the lengths of the two legs. Well, we know that the lengths of the legs are the same. We know that the hypotenuse is the leg times the square root of 2. So here we have an equation. The leg times the square root of 2 equals 3. So dividing both sides by the square root of 2, and then we can rationalize. So we have 3 square roots of 2 over 2. And we now know the lengths of our legs. So some of the things that you need to be able to do is use the Pythagorean theorem to find the lengths of missing sides. You need to be able to, given a 30, 60, 90, and one of the sides, find any of the other sides using those special ratios. Given a 45, 45, 90, and given one of the sides, you need to be able to find all the other sides. And then you need to be able to find complementary and supplementary angles.